Imagine you never stop growing. From the moment you are born until the moment you die, your body just keeps getting bigger. Every year, every decade, no ceiling, no stopping point, just relentless, unstoppable growth. And here's the part I want you to really sit with. The only way you survive, the only way you can keep living, is to regularly rip your entire body out of its own skeleton. Not a metaphor, not a figure of speech. Your claws, your tail, your shell, everything. You have to tear yourself free from the outside of your own body, soft and exposed and completely vulnerable, and then rebuild from scratch. Every single time you grow, that is the price. Now, before I tell you which animal I am talking about, I want you to sit with that image for a second. Because when I first came across this, I genuinely had to put my phone down. Not because it was dramatic, because it was real. And because the animal at the center of this story is one of the most misunderstood creatures on the planet. An animal the internet has turned into a symbol of immortality. A creature people share memes about, post facts about at dinner parties. It is the common lobster, and the truth about how it actually lives and dies is nothing like what you have heard.
Hello, if the ocean's mysteries fascinate you, you're one of us. Subscribe now, let us build this community together.
You have probably seen the claim. Lobsters are biologically immortal. Their cells do not age. They live forever unless something kills them. It travels around the internet every few months, lands in someone's Instagram caption, gets quote tweeted 10,000 times, and then disappears until the next cycle. And here's the thing. It is not entirely wrong, but it is not the whole story either. And the part that gets left out is the part that genuinely kept me up at night. Let me explain the science properly, because it actually matters for what comes later. Every living cell in your body, in my body, in every animal on Earth, contains DNA. And at the very tip of each strand of DNA, there is a small protective cap called a telomere. Think of it exactly like the plastic tip at the end of a shoelace. Its entire job is to stop the strand from fraying. Here's the problem. Every single time a cell divides, that tip gets a little shorter, a little more worn down, and eventually, after enough divisions, the tip is gone. The cell can no longer divide properly. It starts to malfunction, to break down. That is aging at the cellular level. That is why your muscles weaken, and your organs slow, and your body eventually stops being able to repair itself. In most animals, including us, the enzyme that could theoretically repair those tips, it's called telomerase, is largely switched off once we reach adulthood. The clock starts ticking, and it never stops. Lobsters never switch it off. A lobster produces telomerase continuously, not just when it is young, not in bursts, every day, for its entire life. Its cells keep dividing cleanly, no fraying, no breakdown, no slow crawl toward the cellular death that every other creature I have just described cannot escape. Scientists have tested lobster tissue from young lobsters and very old lobsters side by side in a lab. The results were frankly strange. The old tissue showed almost no signs of aging, no degradation, no meaningful difference. It was as if the animal's biology had simply refused to follow the rules. Now, I want to be honest with you here, because this is where most videos about lobsters either oversell the science or skip past something important. Telomerase is not immortality. It is one piece of a much more complicated biological puzzle. DNA still sustains damage from oxidative stress over time. Cells can still malfunction from causes that have nothing to do with telomere length. There has never been a definitive study proving that lobsters producing telomerase throughout adulthood actually extends their maximum lifespan in the way the internet suggests. What we can say with real scientific confidence is this: lobsters do not age the way we do. Their fertility does not decline. Their organs do not deteriorate on the normal animal timeline. A 90-year-old lobster is not weaker than a young one. In fact, many of the largest, oldest lobsters ever studied were more fertile and more physically powerful than any lobster half their age. So before you feel sorry for them, don't. Not yet. Because what actually kills them has nothing to do with aging. It is far stranger and honestly, a little darker. It comes down to one physical flaw that their incredible biology can never escape, no matter how perfectly their cells keep repairing themselves. Remember the image I opened with. the body tearing itself free from its own skeleton. That is molting. And for a lobster, it is not occasional. It is not a once-in-a-lifetime event. When a lobster is young, it molts several times a year. Each time it absorbs water to expand its body, cracks its old shell from the inside, and then slowly, over the course of hours, hauls its soft, exposed, entirely unprotected body out through the back. During that window, the lobster is completely defenseless. No shell. No armor. Just exposed flesh on the ocean floor, waiting for a new exoskeleton to harden around it. Predators, disease, infection, all of it is on the table. Every molt is a gamble. But here's where the story turns dark in a way I did not expect when I first went down this rabbit hole. Because the lobster never stops growing, and because it can only grow by molting, the molt never ends. It just keeps happening. Year after year, decade after decade. And here is what that actually means at scale. A lobster that has lived 50 years can stretch over 70 centimeters and weigh more than 20 pounds. That makes it roughly 600 times longer, and, I want you to hear this number, approximately 1 million times heavier than the day it was born. I found myself trying to put that in human terms, and I genuinely could not get my head around it. So I ran the math. If a human baby grew at the same exponential rate as a lobster, by the time that person turned 50 years old, they would stand nearly 1,000 feet tall. They would weigh over 3,000 tons, heavier than a fully loaded passenger jet. That is not a body any biology can sustain, and it is exactly the problem. The energy crisis, where immortality becomes a sentence of feeling. As the lobster grows larger, every molt demands more energy. The shell grows thicker. Breaking free from it requires more force, more metabolic fuel, more of everything. A young lobster molts easily, almost casually. An old lobster, a 50-year-old, a 70-year-old, might spend years simply preparing its body for a single attempt. Years. To molt once. And during that entire preparation period, it is still living inside its old shell, still constrained, still growing a body that the shell is increasingly failing to contain. Between 10 and 15% of lobsters in their mature years die every single year just from the effort of molting. The process that keeps them alive is simultaneously the thing most likely to kill them. And then, for many of them, the molt simply stops coming altogether. Not by choice. Their biology does not give up. Their cells are still replicating, their telomerase is still working, their body is still signaling, still pushing, still trying to grow. But the infrastructure cannot keep pace with the biology. The energy required for the next molt exceeds what the animal can generate. And so the lobster stalls. Right at the edge of the process it has been performing its entire life. It never molts again. What happens next is what I kept coming back to. Because it is not fast, it is not dramatic, it does not look like the cinematic death scenes we associate with powerful animals. Without a fresh shell, the lobster is stuck. It cannot grow. It cannot move with the power it once had. And inside that rigid, dead exoskeleton, something called shell disease begins to take hold. A bacterial infection that spreads through the shell itself, rotting it from the outside in, sometimes fusing the lobster's body to the interior of its own armor. Autopsies of large, ancient wild lobsters show evidence of muscular deterioration, internal organ strain, structural collapse from within. Things you would never find in a lobster in its prime. Their biology is still ready, still fighting, still producing the enzyme that was supposed to make them last forever. But the body that biology lives in has simply run out of road. Director's note: the line "it never molts again" should land with a full 2-second silence. Do not rush past it. That is the emotional center of the entire video. Now, every story about biological limits has its outliers, and lobsters have some extraordinary ones. In 1977, a fisherman working off the coast of Nova Scotia pulled something out of the water that stopped everyone on the boat. The lobster weighed 44 pounds, measured over 3.5 feet long. Scientists who examined it estimated it was at least 100 years old, though I should be honest with you about something here. Aging a lobster is genuinely difficult. When a lobster molts, it sheds its entire exoskeleton, including the digestive tract and internal structures that in other animals leave measurable growth markers. There are no rings to count, no hard parts left behind. Size and shell condition are the best tools researchers have, and neither is perfectly precise. But by any reasonable measure, that animal had been alive for a century. Then there is George. If you have spent any time in lobster content online, and apparently I have, you have probably come across him. George was caught near Newfoundland and briefly held in a seafood restaurant in New York City. Experts estimated he was around 140 years old. The public found out. There was outrage. People campaigned for his release, and eventually George was returned to the ocean, to what most people assumed was a triumphant return to his kingdom. Marine biologists had a more complicated reaction, because a lobster of George's age and size is not a king in his prime. He is an animal at the absolute edge of what his biology can sustain. At that scale, the energy required to molt successfully is almost certainly beyond what he could generate. His shell would have been thick, scarred, calcified in places. Some large lobsters of that age can barely move their own claws, not because they are weak in the way we think of weakness, but because the machinery of survival has quietly, incrementally ground to a halt. The ocean George was released back into was not a homecoming. It was, for a lobster in that condition, most likely the final chapter. I found that genuinely hard to sit with when I first understood it, because we look at these enormous ancient lobsters and we see power, we see survival. We see an animal that beat the odds for a century and a half, and in some ways that is true. But look closer, and what you are actually seeing is an animal that grew too large for the only mechanism keeping it alive. A creature whose very success, its size, its age, its decades of survival, has become the architecture of its end. The bigger it got, the closer the trap closed. For all the mythology around lobster immortality, the actual average lifespan in the wild is around 31 years for males and 50 to 60 years for females. Not forever. Not centuries, a fraction of what the viral claim implies. And the reason is not predators, though predators take many. It is not disease, though disease takes more. It is not a flaw in the telomerase system, or a failure of the cellular biology that everyone points to when they say the word immortal. It is physics. The lobster's biology is essentially perfect. By the standards of cellular aging, it has cracked the code. But it lives inside a physical world that does not care about cellular perfection. A world with gravity, with energy limits, with the hard math of what a body can sustain at a given size. What I keep coming back to, what I think is the real reason this story is worth telling, is not that lobsters are immortal. They are not. It is that the thing that makes them remarkable is also the thing that seals their fate. Their cells never stop repairing, their body never stops growing, their biology never stops pushing forward, never stops signaling that there is more life ahead. And all of that is true, right up until the moment the shell around them becomes something it was never supposed to be. Not armor, a cage. They do not age out, they max out. And there is something about that. An animal whose only failure is that it refused to stop, that I find hard to shake. The lobster does not die because its biology gave up. It dies because its biology never did. If you made it this far, I want to know something. When you next see a lobster, on a menu, in a tank, in a nature clip, what are you going to think about? Because I will be honest, I have not been able to look at one the same way since I went down this rabbit hole. And I am not entirely sure whether that is sad or fascinating or both. Drop it in the comments. And if someone you know would see this completely differently, send it to them. The argument is half the fun.